If an oldster asks you about Twitter, tell them it's like sending a postcard. I send postcards to my millennial children. I call them paper tweets. Sometimes I include hashtags. You should send a postcard to your granny. It will be the highlight of her day. She will put it on her social media wall with a refrigerator magnet so all her friends can like it. So I'm here in the historic Wren building at the College of William and Mary with Spencer Kirn. I'm Professor Mark Hinders in the Applied Science Department. Spencer's a PhD student here at William and Mary, and we've just published a paper on using topic modeling to track tweet storms. I assume you've heard about fake news. I hope you don't believe everything you read on the internet. We've come up with a way to use wavelet fingerprints to tell the difference between different kinds of tweet storms, ones that blow up organically and others that are pushed by Twitter bots. So Spencer, maybe you can tell us a little bit about topic modeling?
Yeah, so topic modeling is basically a generic term for using either statistics or linear algebra or some combination of the two to find a whole lot of commonly co-occurring terms in a set of in our case, millions of tweets. So we were able to take all these tweets and compress them down into 20 or so different topics that we then track through time.
Okay, and so we make time series plots of topics inside of millions of tweets, and then we perform a mathematical operation on those time series called a wavelet transform, and we render a time scale image, and we do that in a black and white form that kind of looks like fingerprints, so we call those wavelet fingerprints, and then shapes inside those wavelet fingerprints allow us to distinguish different kinds of things inside of tweet storms, which we're calling storm cells?
Yes.
Okay, so maybe you could talk a little bit about the data you've been looking at?
Yeah, so we kind of just found a bunch of different tweet storms that we thought had some kind of cultural impact. So we had things like the World Cup and the Olympics, but then also for a lot of major news stories, I had to hop off my couch, run into campus, and turn on the tweet streamer for the Robert Mueller report or for the Kavanaugh hearings.
So we did Freddie Gray as well.
Yes. So we have we cast a wide net of different kinds of tweet storms, so we weren't just overtraining towards one.
Okay, and so we've shown that this works. We can tell the difference between different kind of tweet storms, and but those we accumulated the tweets, lots of them.
Yes.
Hydrated the tweets, is that the word?
Yes, for some of them, we had to hydrate them.
Okay, and then we processed them offline in order to see if we could see what fingerprints we could extract from them that told us different kinds of tweet storms.
Yeah.
Right? And now you're porting this to GPU on the supercomputer, and we can do it real time, you think?
Yeah, so that's kind of what we're working on now. We're using the campus GPU capabilities because we want to make this real time, because if we're trying to track fake news, we want to catch that early. To catch that early, we need to be able to track topics and tweets in real time. Okay,
and you also, for what, a month, you captured everything happening?
It was about 10 days. I have a tweet streamer going and just streamed every single tweet that came in.
How many tweets was that?
It is about 20 million tweets, I think.
Okay.
Is
that a lot?
That is a lot. Yeah.
Okay. All right. So we'll put the details about this paper in maybe the description of the video. But again, you can look us up on the internet, William and Mary Applied Science Department. To make a postcard if you want. But email's probably a better way to find either me or Spencer. Let's talk for a minute about deepfakes, right? Because part of what we're after here is identifying deepfake videos. I hope you've heard about these. These are really quite frightening, where with freely available software on sort of a gaming level computer, you can make highly convincing videos of people doing and saying things they didn't say or do. And our sense is that these are going to be so good that you won't be able to analyze them to tell real from fake based on the content of the video. And so what we have in mind is instead analyzing how the video spread through various social media, right?
Yeah.
And
how a video moves from, I don't know, TikTok to Facebook to the evening news, or Reddit to Facebook to the evening news. The idea is to identify how it's spreading, the comments that are being said about them, the content of those, analyze that with the topic modeling in order to distinguish real from fake before they make the jump from the sort of lower level social media to the mainline social media to the larger consciousness, and call bullshit on the ones that are bullshit before that all happens. Is that about right?
Yeah, it's a constantly evolving thing. I think right now the main detection or the state of the art of detection is people are tracking blinks and all of that. That seems to work well, but that only works well until there's a software upgrade and the fakers find a way around that.
And they will.
Yeah.
So I hope you don't believe everything you see on the internet. I certainly hope you don't believe everything that you see on social media. All right, thank you.
We'll put more information about this and other projects on our webpage. You can find us at Applied Science Department at William & Mary, as.wm.edu. Feel free to look up our contact information there. Send me an email. I don't do Twitter.